Hello guys. So in this video we will learn and understand what are the different kinds of architectures that we can have in RNN. Okay, that is recurrent neural networks. This is going to be a short video, just a theoretical part. So and it's going to be important also. Okay, so please go through this video till the end. Alright, so let's get started. So the first type of RNN architecture that we can have is many to many, many to many. So wherein we will have multiple inputs and multiple outputs. So as you all know from notations, we know that the length of the input sequence is represented as Tx, length of input sequence, and length of output sequence is represented by Ty, length of output sequence, right? So in many to many, this can be Tx can be equal to Ty, or they both can differ. They may not be equal, right? So while explaining forward propagation and backward propagation, I have taken the example where Tx is equal to Ty. Okay, so for every one input at each time step, we will have one output. So if we have input at time step 1, we will have the output at time step 1. So like this, we will have till the end of the time steps. And when it comes to Tx not equal to Ty, this will be generally this will be the case. Okay. Generally, this will be the case. And where this many to many architecture would come into effect? So it will come into effect mainly when we are dealing with machine translation. Okay, machine translation, and there is something called as named entity recognition, NER. So given a sentence, you need to identify what are the verbs in it, what are the nouns in it, okay, etc. So that comes under the category of named entity recognition. So this is called as named entity recognition. And when it comes to machine translation, I'm actually talking about translation from one language to another language, right? So maybe from English to French, right? Or English to Hindi. It could be English to some local language, Kannada. Yeah, it can be anything, or it could be English to Arabic, or the other way, right? So Russian to English, something like that. So you can have any language translation, and it could be Hindi to Sanskrit or vice versa, both, right? So it can be other way also, right? So these all comes under the category of machine translation, or translating from one language to another language. So in this case, the input sequence, length of the input sequence need not be equal to length of output sequence. So what we do, we usually have something called as encoder and decoder architecture. Encoder and decoder architecture. So how this will look like? So it will have the inputs. Okay. So I'll have the inputs. So these are all RNN blocks. You can think of them as RNN blocks. Okay. So I'll have the inputs, and once I'm done with the input sequence, maybe it may be represented with end of sentence token. So EO stands for end of sentence. Okay. So once it is done, then we will start our decoder block. Okay. So this will be taken as input. We will have the decoder blocks starting from the end of our encoder block, right? And this will be our y hat t minus 1, something like this. Okay, so this is called as encoder, and this side is called decoder block. So what happens, in order to translate the language correctly, we need to first listen to the sentence till the end, then only we can have it translated in a proper way. So that's why we will not have any intermediate outputs before the sentence completes. We will read in and try to understand the entire sentence at once, and then we will have the decoder block where we will try to translate it into the desired language. Okay, so this is encoder decoder architecture. We will see in my next upcoming videos how to implement encoder decoder architecture. We will talk through everything, and we will also implement each and everything. Okay, so this is about many to many architecture. Now there is something called as many to one, right? So this is second type of architecture, many to 1. So what is many to 1? So we'll have multiple inputs. We'll have inputs at multiple time steps. Okay. And we'll have only one output at the end of the time step. So this is called many to 1. We will have inputs at multiple time steps, no outputs till the end. So we will have only one output. So where this usually employed, this kind of architecture, this can be, let's think, this can be utilized during sentiment analysis, right? Sentiment analysis. Also we can have it utilized during the text classification if we are dealing with different types of text that we have to classify, right? Text classification, or it could be document classification. So it could be anything. So basically the sentiment analysis can also be treated as a classification task in one way if we are making a supervised learning, right? So basically this kind of many to one architectures would be used in classification tasks and sentiment analysis problems, right? So this is about many to one. Now there is something called as 1 to 1. So this is just for the sake of completion. So this is not actually a RNN. You cannot, even if you do not think this as an RNN, that's okay, because for every input we will have an output. So this can be treated as a standard neural network also. Standard neural network, right? So this is 1 to 1. And the last one which I can think of is the reverse one, 1 to many. 1 to many. So this is again interesting. So what happens? This will generally be used for sequence generation, right? So we input just one word. It could be subject or object or some act that could be an input to the model, and this model goes on generating multiple sequences, and it will stop after encountering end of statement token or at the specified length of the sequence that we want, right? So this is called a sequence generation. You can also think of this, you can also think of another example which could be music generation, right? We can also use one to many architecture to generate the music. So what you can do, you can just provide an input, a starting tone or note. You provide the note of the music, starting note of the music, and from there on the model will generate its own notes, and it could altogether be a different music that might not exist till now, right? So these are all the different kinds of architecture that we can implement and employ with respect to RNNs, recurrent neural networks. Okay. So this is it about this video. In my next video, I want to talk about how do we address the issues with respect to RNNs, how to address the issues. So I have already made a video on what are the problems or issues associated with RNN. So in my next upcoming video, I will talk about how we can address that. So we will talk about GRU. So this is called as gated recurrent unit. And we'll also talk about LSTM. So these are all RNNs only. So GRU RNN, LSTM RNN, you can call them. So LSTM stands for long short-term memory. Long short-term memory. Okay. So this is really interesting, and we can also have something called as bidirectional RNNs. Bidirectional RNNs. So what do I mean by bidirectional RNNs? I'll talk about this in detail during that video, but just think that we will also have the inputs to the model from the time in future, right? So that it can understand the context before predicting the word. It can understand the context associated with the word before and after it, right? So in some way we can achieve that. So that we will deal with bidirectional RNNs, and specifically it will be LSTMs, bidirectional LSTMs. Okay. So that's it for this video, guys. Hope you like this video. It's a short video, completely theoretical. You can explore more on this. I'll also make in detailed videos on all these architectures once I cover gated recurrent units and LSTMs, right? So we will deal with everything: encoder, decoder architecture, machine translation, We will also do some sentiment analysis, text classification, everything we will implement in Python using Keras library. Okay. So if you like the content that I am creating, please give it a thumbs up, share it to your peers so that they can also be benefited. And it will also help me to keep motivated and produce the contents like this. Okay. Good contents like this. So that's it for this video, guys. Hope you are enjoying the learning. Till we see in the next video. Happy learning. Bye bye.